Hey guys, welcome to our first lesson in Unit 2, and we are going to talk about graphing rational functions. And to do this, we're going to really talk about three different things: identifying asymptotes, graphing it, and finding the domain and range. So before we really jump into rational functions, let's just talk about the jobs of A, H, and K. So notice we've got two different types of functions here. We have an absolute value function that makes the v, and we have a parabola or a quadratic function which makes a parabola, but the jobs of the A, H, and K are the same. So let's talk about that. So the A, that made the graphs fat or skinny. So if I had like y equals 3x squared versus y equals 1/3 x squared, the 3x squared would make it skinny, the 1/3 x squared would make it fat. Also, if A is positive, it made my parabola or absolute value open up, and if it was negative, it would make it open down. Okay, so the H, poor H, he was always attached to the X, and we can't trust him. He's a liar. So, so whatever it tells you, you're going to do the opposite of. So, and this also helps you, or helps to know that you move it either left or right. So if I have y equals the absolute value of x minus 3, then I remember it's a liar, so I moved it to the right 3. And then finally K, this helped us to know that we moved it up or down, and it is what it is. He's not a liar. So if I had the absolute value of x minus 1 plus 2, this is our K, and we would go up 2. So those are the jobs of H and K that we've talked about before. So let's kind of move on to what a rational function looks like. So this is what just a regular old plain Jane parent function of a rational equation looks like, and this is what its graph looks like. And so it talks about these asymptotes. An asymptote, I kind of think about it as like an electric fence. So notice how the graphs get really, really close to the electric fence in both directions, but they never touch the electric fence, and they definitely never pass the electric fence. So it just kind of like keeps them inside their space. So if we took this graph and moved it around, that's where the A, H, and K comes into play. And this is like when our graph is going to be moved around or changed as far as how far out it goes. So we're going to talk about that in a second. So this is just writing out the steps that we're going to take when we graph it. So notice the first step. We're not going to just like jump right into the graph. The first step is we are going to draw our asymptotes. So our asymptote is going to be like x equals a number and y equals a number. X equals is going to be that VA stands for vertical asymptote, and the y equals a number, that's going to stand for our horizontal asymptote. So notice the y equals a number. We talked about this before. It's a line, a horizontal line, and x is that vertical line. Okay, and then what we're going to do is we're going to plot 2 points to the left and 2 points to the right of the vertical asymptotes. And then we're going to draw the 2 branches of the hyperbola. And so we're going to just go through these steps. It's probably easier just like jump in and do a problem. Okay, so we keep bringing up domain and range when we're talking about graphs. So our domain and range is going to depend on H and K because that's where our asymptotes are going to come into play. So if you'll notice, like for our domain and range, like it breaks here. It cannot touch that. It cannot touch that. So if you'll notice, like our domain is going to be the set of our reals except our vertical asymptote, and whatever the h value is. It can't equal that. Our range is going to be all real numbers except the horizontal asymptote, and it cannot equal k. Okay, so I think I've covered everything that we need to cover ahead of time. So let's just kind of go in, just jump right in with both feet, and let's graph this. Okay, so the first thing I want you to think about is when you have this graph, what are A, H, and K? So let's go up to this right here. So notice our A is going to be -1 in our equation or in our function. And notice there's no H or no K. That's okay. They're just 0. So we have -1, 0, and 0. So now I want to draw your attention to the 3 steps. So the first step is to draw the asymptote, and it tells you that x equals our h value. So x is going to equal 0. That's a line, and then y is going to equal 0. And that's our, it's a line, and that's going to be our horizontal asymptote. So let's go ahead and do those 2 things. So x equals 0 is going to be right here, and y equals 0 is going to be right here. And those are our vertical asymptotes. I don't know why I drew it like that. Vertical asymptotes and horizontal asymptotes are represented by a dotted line. So even though it is a line, because our asymptotes, we're going to identify them with dotted lines. Okay, so now that we've done that, let's go up to step 2. So step 2 says plot 2 points to the left and 2 points to the right of the vertical asymptote. So notice I don't care about the horizontal asymptote. So if our vertical asymptote is 0, let's see, 2 to the left would be -2, -1. 2 to the right would be 1 and 2. Let's go ahead and plug those in and see what happens. So let's see, if I plug in -2 right here, I'm going to get 1/2. And so go ahead and just fill in the other 3. Okay, so you should have these values, and what we're going to do is we're just going to plot them. And I think what I'm going to do is I'm going to make each of these dots 1/2, so we can kind of see it a little bit easier. So there's -1, -2, 1/2, and then -1, 1. And then I'm going to do the same thing over here. So 1, -1, and 2, -1/2, so that it looks like this. Okay, so let's go up and see what is next. So we did that. Let's see, draw the two branches of the hyperbola. Remember, they should not cross the asymptote. So I'm going to extend that. It goes beyond that, so like they can't even touch it. So we're going to, it's going to approach it up here. It's going to approach it over here. And it's going to look like that. So it's getting very, very close to them, but it never touches or crosses them. Okay, and the last thing I want to do is talk about the domain and the range. So we saw that here. So the domain is going to be the set of all reals, and then x cannot equal whatever h is. So remember, our h was 0 and our y was 0. So it's going to look like this. Our domain is going to be the set of all reals. Our range is going to be the set of all reals, except, oops, that should be next. X cannot equal 0. So it's just whatever your vertical asymptote is. And for the range, y cannot equal 0. So it looks like that. Okay, so notice this one is a little different because it has the -2. And so the first thing I want to do is identify our A, H, and K. So go ahead and do that. Okay, so I'm going to take that H and K and I'm going to apply them to my vertical and horizontal asymptotes. So notice it's just x equals whatever h is and y equals whatever k is. And so I'm going to go from there and I am going to go straight to my domain for my vertical asymptote and my range to my horizontal asymptote. Because again, notice, keep it consistent. Keep the x's together, keep the y's together. So I'm easily able to answer those 4 pieces right there. So if you'll remember, our step 2 was to do 2 points to the left and 2 points of the right to the right of the vertical asymptote. So again, our vertical asymptote is 0. So that is going to look like this. And so I'm going to take each of these and plug them in to my graph or my function and see what I get. Okay, so I found the points and then I plotted the points over here. So really, I just want to point out, I kind of went back and forth whether I wanted to do half or whole. So I just want to show you what it looks like if you do a whole. It's just really, it doesn't give you a lot of information. So you need to know the look of the hyperbola that you're creating. So remember, it goes towards the asymptote, in both directions, so that it will look like that. Okay, so to remember to find the x-intercept, we're going to set y equal to 0 and solve for x. So let's see, I have 2 equals 1 over x, and so x is going to equal 1/2. So that is a proportion. So my x-intercept is 1/2, 0. Let's see if that makes sense. Yes, that makes perfect sense on my graph. Okay, so for my y-intercept, I'm going to set x equal to 0. So y equals 1 over 0 minus 2. You're going to see that is undefined. We have a 0 on bottom, so that doesn't work. Let's see why. Oh, look, there's an asymptote right there. So at x equals 0, there's an asymptote, so that's not good. So we do not have a y-intercept. Okay, so for this one, see if you can do these 4 steps. Okay, so it should look like this. The only translation that's going on is it's moved to the right one, and it's because of that that piece that tells us that h equals 1, so it's moved to the right one. Okay, so let's go ahead and mark our vertical and horizontal asymptote and then graph our 4 points. Okay, so I plotted my vertical asymptotes and my 4 points, and so I'm going to go ahead and graph the rest of my hyperbola so that it looks like that. Okay, so go ahead and find the x-intercept and the y-intercept. Okay, so the y-intercept, let's start there. That's very mathy. So we're just going to set x equal to 0. And so I ended up with y equals -1. So my y-intercept is 0, -1. For my x-intercept, notice that there is an asymptote on the x-axis. So there cannot be an intercept there because it never touches it. Okay, let's go ahead and do this. See if you can do this entire problem by yourself. Okay, so the graph was shifted to the left 2 because of my h and down 1 because of my k. This is all the information that relates to that. Notice when I created my graph, my XY chart, that the x-intercept and the y-intercept showed up. So that's where I got my x-intercept because y was equal to 0. And this is where I got my y-intercept because x was equal to 0. So that's kind of nice. And we are done.